So then in the last section we were given an equation for a line and we made the graph of the line. And we found some information out about the line. We could find a y-intercept or x-intercept or a slope. So what we're going to do in this section is go backwards. If we are given some information about a line, could we write the equation for that specific line? So some pieces of information that we could be given are a point that it goes through. Maybe we're told the slope. Maybe we're told the y-intercept. Maybe we're just told 2 points that a line goes through. Or maybe we're told about a point that it goes through along with a parallel line or a line that's perpendicular to the line that we want. So can we take any of those pieces of information to get the equation for the line that we want? So the easiest case that we could get is given the slope and the y-intercept, because we're trying to write this, we're going to try to write these into slope-intercept form, which is y equals mx plus b, mx plus b. And so really the only things that we have to fill in are the slope and the y-intercept. Those are the two pieces that we need to put in there. The y stays, the x stays. So we need to know the slope and the y-intercept. Well, if we're given the slope at the y-intercept, this should be absolutely no issue, right? We just plug in the value we're given for the slope. So we're given a negative 1/3 for the slope, x, plus b, our y-intercept. Our y-intercept is at 0, 2. So plus 2. So easiest case is that we are given the slope and the y-intercept, but that will not always be the case. Another case could be that we are given 2 points that the line goes through. So on this one, our line goes through the points 0, -3, and 2, 1. So again, we're trying to put this into slope-intercept form. So we need to find a slope and we need to find a y-intercept. Well, between 2 points, we know how to find the slope. We can use the slope formula. So I'm going to do -3 minus 1 over 0 minus 2. And that gives us a -4 over -2, which is a positive 2. So the slope that we want is 2. So we're at this point. We know it's going to be y equals 2x plus b. So we just need to find b still. Well, we know a couple x's and y's that we could put in there so that b would be our only unknown. So I'm going to use the point 2, 1. Right? We know that x is 2 and y is 1. So I'm going to put in 1 for y and 2 for x. So we have 1 equals 2 times 2, that x coordinate, plus b. And now we can solve for b. So 2 times 2 is going to be 4, so -4 from both sides. And we get -3 is b, so our y-intercept is -3. So back to filling that into here. Y equals 2x, so the slope that we found, plus, not plus, we'll just do minus because it's a negative, -3. Now I went through a little bit longer than we maybe had to, because maybe you noticed from the start that this point, 0, -3, is the y-intercept. So once we found the slope, we actually know the slope and the y-intercept, and so we could have skipped this little bit of work here. But I went ahead and did this because these are the steps that you might need to follow if you're just given 2 points and neither of them happens to be the y-intercept. So those are the steps you'll need to follow if you're not lucky enough to be given a y-intercept. We could be given a point that our line goes through, as well as a parallel line or a perpendicular line. So again, we're trying to fill into y equals mx plus b. We don't have either of those right now, but what information can I get from a parallel line? Well, if we want a line parallel to y equals -4x plus 1, parallel lines have the same slope. So the slope for the line that we want also has to be -4. So we know y equals -4x plus b. And now we're at the same point we were on the last one, where we have our slope plugged in, and we have a point where we can plug in the x and the y to help us find b. So we're going to put -5 in for the y, and -3 for the x. So we have negative 5 equals negative 4 times negative 3 plus b. Negative 4 times negative 3 is a positive 12. Subtract that 12 from both sides, and that gets us, it looks like a negative 17 for b. So y equals our slope of negative 4, x minus 17. I'll give you a warning that the common mistake that I see on these is a lot of people will just give this line as their answer. But the only piece of information that we can get from the parallel line is the slope. This y-intercept has absolutely nothing to do with our line going through this point. So this right here is extra information that we don't need. This could be a plus 100, and our line would still be this exact same one right here. This is just going to shift our parallel line closer or further from the line that we want. It's not going to change the slope or anything. So ignore this. The only thing that we can take away from the parallel line or the perpendicular line is the slope. So I guess the fourth case, the last case that we might have, maybe we're given a point that it goes through, and then we're given a perpendicular line. So again, trying to fill in y equals mx plus b. And what can we get from a perpendicular line? Well, we know the relationship of slopes between perpendicular lines. So if the slope of this line is a positive 1/3, the slope of the line we want is the opposite reciprocal. So if it's a positive 1/3, the opposite reciprocal is going to be a negative 3/1. So that's just a negative 3. So now, again, we're in the same boat where we were before, where we know y equals negative 3x plus b. And we have an x and a y that we can plug in order to help us find b. So I'll leave you to do that last example on your own. But again, the only information that we can get from a perpendicular line is the slope. This plus 3, this y-intercept of our perpendicular line has nothing to do with the line that we want. So don't take any information from there. Okay? So finish that one up, and then I think you guys are going to be good for this section. Again, this is something that you did in Algebra 1 and Geometry, so now you're doing it again in Algebra 2.